Okay, the last topic of the year to review, ecology. All right, we have a bunch of vocabulary in ecology, which is essentially the entire topic. So we have 8 words here that need to find their match. So we have the things in the environment that are living, the things that are non-living, all the members of a species in a given area, all the different species in a given area, and then all the different species and the non-living stuff in an area. We have organism's job and organism's home. And I threw in one more word that we didn't learn earlier. It's just a general vocabulary word, but it shows up on the Regents a lot in this section, and it's a word that means limited. It's the opposite of something that would be infinite. Okay, I'm going to give you a moment to figure out what those are, and then we'll go through them. All right, so living factors. Bio means life. Biotic factors are living. Abiotic, when you put A in front of a word, it means not. These are the non-living things. All the members of a species in a given area, like all the white-tailed deer in New York State, would be a population. But once you add in all the deer and the foxes and the plants and the berries and the birds and all the different bacteria and all the different species within that area, like New York State, you're now looking at a community. Those are the biotic factors. But then when you add water and air and the temperature and the climate and everything else with the community, you have an ecosystem. Organisms fulfill a certain role within the ecosystem. For example, plants trap sunlight energy in sugar and produce sugar that other organisms then eat. Their job of doing photosynthesis is their niche. Plants can live in the forest. That would be an example of their habitat. Now, the word that comes up often in this section on the Regents is finite. Things are finite if they're limited. We have finite number of resources. They're limited. It's the opposite of infinite, which we usually pronounce infinite, non-ending, not limited. Okay, so moving on to flow of energy within the ecosystem. Remember that ecologists look at an ecosystem as essentially a bunch of different vessels for the movement of atoms and energy. And they represent those in food chains and webs or energy pyramids. In the case of food chains, arrows point from the eaten to the eater. So for example, an arrow might point from a carrot to a rabbit. That shows that energy is moving from the carrot into the rabbit. In this case, the carrot is the producer and the rabbit is the primary consumer. And then that energy can move into a fox. In this case, the rabbit is the primary consumer and the arrow moves into the fox. It's the secondary consumer. You can show how all different food chains are interconnected in an ecosystem through a food web. Now, energy is used up at every step of the way. The carrot actually does things like active transport. The bunny does things like hop and active transport. And the fox does things. And so all the energy that the carrots trapped in their bodies from the sun is some of it's used up. So it's not all available for the bunnies. And then the bunnies, whatever they eat and goes into their bodies, it's not all available for the foxes because the bunnies actually hop some of it away and produce heat. And so we have a decreasing number of individuals and amount of energy at each stage. So there's always going to be more producers and more energy in the producers and more biomass in the producers than there are in the primary consumers, than there are in the secondary consumers. And so when you have a pyramid like this, you're always going to have the producers at the bottom. You're always going to have the primary consumers right above them, and then the higher level consumers at the top. Some more vocabulary. We have all of these terms that we have to get into all of these words. So I'm going to give you a moment to see if you can fill those in. All right. Who makes their own food? One word we learned is autotrophs. In the ecology framework, we use the word producers or autotrophs. Consumers or heterotrophs eat food. Of course, they're specialists. Some eat only dead food. Those are scavengers. And some hunt and kill for their food. They're predators. The predators hunt and kill their food. Their food are called prey. Some animals only eat plants They're herbivores. They will always be primary consumers. Some organisms only eat animals. They're carnivores. They will never be primary consumers. They'll be secondary or higher order consumers. And then some eat both plants and animals. They're omnivores, like us, like bears. Sometimes we serve the role, the niche of being a primary consumer, when we eat plants, and sometimes we're a secondary consumer when we eat meat. We are never a producer because we don't have chloroplasts in our cells to trap energy and do photosynthesis. So we are never producers, but we can be primary consumers or secondary consumers depending on whether we're eating plants or animals. And then finally, there's a really, really important group, as important as producers. You cannot have a self-sustaining ecosystem without them, and that is the decomposers. They are not scavengers. They rot stuff and recycle it into form that producers can use. They recycle atoms and break them down into inorganic compounds that the plants can use. Plants then get a constant source of energy from the sun and trap the energy amidst those materials the decomposers hand to them and make organic compounds like sugar that the consumers can then eat. You cannot have a self-sustaining ecosystem without producers, and you can't have a self-sustaining ecosystem without decomposers. You can do without the rest.